So let's talk about how we're going to perform our experiment. Determining the density of a liquid is very easy because all you do is you weigh a graduated cylinder empty, then you add your liquid, and you can just read off the volume of your liquid, and then you can reweigh it, subtract off the mass of the graduated cylinder, and you'll have the mass of the liquid. To get the density, you know that it's mass over volume, and grams is mass, and 9.1 milliliters here. Let's watch what we did with the sig figs and the units though. So my calculator says this, something like this. How many significant figures do I want though? There are a whole bunch here, 5, and here, but here there's only 2. So our volumes will usually have fewer significant figures. So to round this to 2 sig figs, I'm going to do 1.1 because that rounds up. This digit is 5 or greater. And then for units, we need to look back up here. Those units are still there. That's our units for density in this case. So that's pretty easy. Let's look at how we do the density of a solid. Solids are trickier because it's harder to determine their volume, especially when your solids are like ours. They're little rocks or pellets or little nails. You can't just measure them. We're going to use a trick with water to get their volume. So what we do with water is we add water initially to the empty graduated cylinder. We write down its volume, and then we add our solids, whatever our solids are, little rocks or pellets or beads. And then we read off our volume again. So then we can determine the volume of our solid. All we need to do is subtract these two numbers. And we know the volume of our solid. The mass of the solid, of course, we'll have to weigh the graduated cylinder with just the water, and then we'll weigh it after we add the solid so we can get our density. And then you'll do the same calculation, mass of the solid divided by volume of the solid. In order for this to work, there's a few tips. First, the solids need to be completely under the surface. In other words, if you have some solids that break the surface, their volume is not going to be determined. So if this happens, you can try to tap your graduated cylinder to get those to go back under the surface. That's the easiest way. Better still is to not let them do that in the first place. When you're pouring them in, pour them in slowly and make sure they all fit under the surface. You do not have to use all of the solid that we give you. In fact, my next tip is that you need to use just half of the solid or less per trial. You're going to do each of these determinations twice, and you have a tube of solid that you'll pick up. It has an unknown number on it, and there's more than enough for 2 trials. Some of the tubes have less. On the real dense ones we don't give you as much, but there's enough to do 2 trials and maybe more. So only use half for each trial or less, and then that way for the second trial you'll have some solid that's already dry. Another thing, make sure that you don't let the liquid go over the 10 milliliter mark. If you let your liquid go up here, then when you go to read off the volume, you're not going to know what the volume is. So when you add your solid, you're making sure that all the solid stays under the liquid level, and you're also making sure your liquid level does not extend over the 10. Okay, so those are those 3 tips. Here's some more tips in general about the whole lab. You need to watch your significant figures. When you use that balance, write down every digit it gives you. when you use your graduated cylinder, they're kind of different. Our graduated cylinders aren't marked every tenth. So let me show you. Like this. So when you read that off, say that's our meniscus, we know that this is 9 point something. What is that little line there? That's 9.8, isn't it? Because each of these lines represent 0.2. So there's a line for 0.8 and there's a line for 10, but there's not a line for every digit here. So I'm going to estimate the next digit at 8. And that's all that I can write. There's a line for this one. This one is technically an estimate since there's not a line for every digit there. And that's all I can write. So when you write down your sig figs for your graduated cylinders, go 1 past the decimal. If it happens to land right on 10, then you'll have 3 sig figs, but all of the others will have just 2 sig figs. I already said balance on the balance you record every digit. Don't round those off. Accuracy matters. You're going to be graded for your accuracy. As far as accuracy goes, another thing to watch is make sure that when you're using your graduated cylinder that you're setting your graduated cylinder up on a solid surface, preferably something up high, and then bending down and making sure you're looking at it straight on to read those off. There are a few places in the procedure where you need to make sure your graduated cylinder is totally dry and clean. Make sure you do that. A few drops of something in there can throw things off. Each of the density determinations you'll do twice. You'll do an unknown twice, you'll do water twice, you'll do the unknown solid twice. If your trial 1 and 2 aren't close, come see me. And what I mean by close is if you get 8.5 and 8.7 for your 2 densities, that's pretty close. But if you get 8.5 and 5.1, that's not very close. So just kind of use your judgment. Ask me if you're not sure. Usually, if we can't find a mathematical error, maybe you had a problem with the balance or something. If they come out really different and we can't find a reason mathematically, then you can do a 3rd trial and decide which of these is not correct, so it won't hurt your accuracy grade. And then also always record your unknown numbers. Unknown numbers are always on tape on the sample when you pick them up.